How to use a gradient to work out a rate of change in 81 seconds. Let's go. Sometimes, guys, we're going to be given a graph like this and be asked to calculate a rate of change. What do we do in that situation? Well, we can use the fact that the gradient of our line is going to give us the rate of change. Let me show you what I mean. The question says that the graph below shows how Tom's speed changes over time on his weekend hike. It then asks us to calculate the rate of change of his speed between hour 5 and hour 7. Guys, what are we going to do? We're going to find the gradient of the line between hour 5, which is here, and hour 7, which is here. Guys, we know how to find the gradient of a line. We're going to do our change in y, otherwise known as our change in height, divided by our change in x, which is going to be how far across we are. What's that change in y? Our change in y in this situation, guys, we're going to go from a speed of 3 to a speed of 6, so it's going to be 3. So our change in y, our change in speed is going to be 3. Let's write that in. So change in y divided by change in x, we're going to have 3 on the top. And what about our change in x, guys? We go from a time of 5 to a time of 7. So that's going to be a change in x of 2. So guys, our answer is going to be 3 over 2, otherwise known as 1.5. Now, what about our units here? Well, let's have a look back at the question. The question says, calculate the rate of change of his speed. Now, what's our units going to be? It's actually going to be miles per hour. So how many miles per hour he changes every hour. We can write that, guys, as miles per hour squared. Let me write that in, miles per hour squared. And that is going to be our answer to this one.